Hey there, welcome back to Pacifica Science. I was trying to roll in like John Green, but he does it much better. Okay, if you check out the board behind me, we've got our notes, our homework, and a little bit about why I've got a baseball cap and a baseball here today. So let's jump on in. Okay, first of all, our homework. Let's get to the nitty gritty, the stuff that you need to know for the grade and all that kind of stuff. Don't forget to send me by tomorrow at 3 o'clock a picture of your 10 vocabulary terms that you can that you defined in your notes. Excuse me. There should have been 7 straight out of chapter 1 and 3 more that we added: atom, molecule, and periodic table, which I'll get to again in just a second, talk a little bit about. Then also our next test will be posted by tomorrow around 3 o'clock. Someone had requested that the tests get posted early, so I said, why not? I'll put the test out there by Friday at 3 or 4 o'clock, but it's not due until Wednesday at 3 o'clock. That seems like a good time during the distance learning to have everything due test-wise. Assignments, they can be due usually by the end of the week. All right, let's jump into the notes. First of all, current events on CNN 10 today was really good, and it directly related to what we've been doing lately. I love that. Again, I didn't use all of CNN 10, but do check it out for yourself. It is a good little 10-minute recap of the news. The first one, they showed good old San Francisco. They showed San Francisco with the red skies about a week ago. Why all the other colors got filtered out and red went on through the atmosphere. Straight out of our notes right there, which is awesome. Remember, the sun puts out light that streams and hits Earth in every frequency, but on, let's see, it was last Tuesday, only the reds were getting through, and it looked very strange around here. And then also biodiversity, which brings me to the baseball. Had an awesome professor up at Sacramento State where I did my undergraduate work, and he compared the tomatoes that they grow up there in Sacramento to baseballs. Why? It was not a complimentary example, let me tell you, because baseballs, of course, are hard, great for playing the game of baseball, not so great for eating, but really good if you want to get a whole bunch of tomatoes to market and you don't want them crushed. In Sacramento, they would take these huge gondolas, the same name as those things that get you to the top of the ski slope. Well, they're these big open trucks where they pour in the tomatoes, and the hard baseball-like tomatoes are actually artificial selection. We grew them like that on purpose so that we can get them to market and they don't get crushed. But the downside of that is not a lot of diversity and they don't taste very good. Around 22, 23 years old, I went over to dinner at a friend's house whose father was really into gardening. I went and checked out his tomato garden. He had all kinds of varieties. When we had dinner that night, he served some of the tomatoes from his garden. I honestly had never had a tomato until I tasted those homegrown varieties of tomatoes. They were fantastic. And I mention that because there's an excellent piece on biodiversity on CNN 10. It's not just about getting taste and getting variety in your food. A lot of our food has been made very bland and very generic because of trying to grow things that will be durable and make it to market and last a long time. Also, and this is important, we are relying on fewer and fewer crops for our food as a whole. For the whole world, we're only relying on a couple main crops. We've got, of course, corn and rice and just a few others. The diversity used to be much greater, and in any population, diversity is important. If all of a sudden you have a fungus or virus that comes along and attacks one of those crops, suddenly we're in trouble in terms of our food supply. So it's one of the things we're going to be talking about this year. We started off the first couple of weeks here at a very high level, and we're kind of zooming in as we go. All right. We did a field trip today on campus, and the field trip went and checked out some red stains on the metals around campus and some splotches on some rocks. Let's go check those out right now. So we started out with atoms and molecules and the periodic table and where they all came from, kind of a high-level view when we started this course, because we want to know where did the building blocks of chemistry come from, because life really is chemistry. If you look at this picture right here, you're looking at some rust at the bottom of a drainage pipe right here in the quad on campus. I brought first period out there with the computer, and I mentioned that because if you were in charge of a mission to another planet, say a mission to Mars that was looking at something like this, and over the course of, say, a month on Mars, you were to see something like this grow, like I've seen it grow on campus. As you know, if you live in Pacifica, things rust pretty quickly here. Metal rusts pretty quickly. Well, it's growing. It's getting bigger. That seems kind of strange. Is it alive? Now, most people correctly identify this. Well, it's rust. It's a chemical reaction. But what's the difference between a chemical reaction of rust and something that's living? They're both getting bigger. They're both growing. They're both apparently using energy. We want to find out. How do you tell if something is alive or something isn't? Our next stop on our tour of campus, checking out is it alive, is it not, was the splotches on the rocks out there. Okay, later on in the year, we're going to find out how much these rocks weigh, what's the mass of these rocks, based on a little simple math and doing a little bit of measuring. But for now, we're looking at those colors that are on there. There's like kind of greens and yellows. Now, we live right near the ocean here. The campus is about 200 meters from the ocean in a straight line. Is this just staining from all the salt air and the fog around here? Is it something left behind by, say, a bird or a gopher or something like that? In this case, it's a lichen. It's actually two forms of life living together in colonies. You've got a fungus and an algae, and they're living, we think, in a symbiotic relationship. If you look at the lichens around campus, again, the challenges to the students, okay, I'll take my notes and yes, that's a living thing. Okay, I'll remember that. But how would you test it? If it was up to you to figure out if that was a living thing or not, you see this, say, through a video camera from another planet. You're on Mars and you look at something like that. How would you know if it's living or not? So continuing with our life is chemistry theme, over here, the next part, the right side of the notes today, and again, I'll put this up there in just a second. I'll scan in a piece of paper that's got the same information on it. But the point of this note was the following. In our textbook, page 118, I asked the students to look up photosynthesis reaction. And our book is great. It does a great job with the stuff. But one thing they just do, they say, well, carbon dioxide and water, they say H2O and CO2, make glucose and oxygen, which is, of course, is photosynthesis. But to really drive the point home, hopefully, about the conservation laws that we did yesterday, check out on the board the actual number and type of atoms involved. If we use our color scheme from a couple of days ago, we've got red for oxygen, black for carbon, using green this year for hydrogen. You've got the same number and type on each side of the reaction, and that is in line with the conservation laws. You can't make or destroy matter in a chemical reaction. When you're talking chemical versus physical reaction, we then walked the camera back here to the back of the room, to the back of your classroom, where we have a flask with water on a hot plate. And the students were challenged to think about, okay, what is going on here? What are those bubbles made out of? We had guesses, which were great. And remember, part of the science is making a good guess. The guesses said everything from, well, the bubbles are air, to their carbon dioxide. But if you check it out, there's not a chemical reaction going on here. This is a physical reaction. We're taking water, heating it up. We're changing its state. It's going from a liquid to a gas. The gas is expanding and leaving the flask. A lot of it is recondensing. I'll zoom in right there. Recondensing on the edge of the flask, turning back into liquid water and dropping back down into the flask. Difference between a chemical versus a physical reaction. The chemical reaction up on the board was all the atoms rearranging themselves in photosynthesis. Here it's a physical reaction. You have water here in the liquid state, water in the gas state, still just water. And finally, here's a picture of the right side of our notebooks today, and also our homework reminder. On the left, you see a picture of photosynthesis, and every atom is accounted for. If you check out the left side, it's got 6 carbons. On the right side, it's got 6 carbons in glucose, and the same number of oxygens and hydrogens on the left as on the right. Again, this gets back to the conservation of matter in a chemical reaction. You can't create or destroy matter. It's really important. And then finally on the right side, just a quick reminder, by tomorrow at 3 o'clock, have a picture of your vocabulary terms sent to me. You know my email by now. Read the text, pages 28 to 31. That'll help you out with some of the answers in the book, and it'll go a little bit into what is life. And then finally, I'll try and get the next test posted out there by about 3 o'clock tomorrow. Have a great weekend, everyone. Talk to you later. Bye-bye.